Okay, we're in section 4 of chapter 5. We're writing linear equations today in standard form. Short lesson. But let's start by recalling standard form for linear equations. Go ahead and jot that form down without saying it out loud. Okay, so let's say it together then. Standard form linear equations are 3, 2, 1. Ax plus by equals c. Ax plus by equals c. We've got to find a, b, and c. And when we do, there is another little note that usually comes up with standard form equations. A and b are paired with variables, right? They're little products, right? A times x, plus b times y. So we call those numbers that come before a variable what? Coefficients. Okay, the coefficients in a standard form linear equation should be integers. So make a little note there. Usually you are asked for integer coefficients. So if you have 1/2 x plus 2y equals 3, you're going to have to blow this equation up so that 1/2 is gone. Let me write that one down. 1/2 x plus 2y equals 3. You see that that's a fractional. It's called a rational number, but it's not an integer, 1/2. Integers may not have partial pieces. They've got to feel whole to us, right? They can be positive or negative whole numbers, basically. So what would you blow this fraction up by in order to get rid of that 1/2? We need an equivalent equation. So what are you going to multiply by? Lauren, what would you multiply by to get rid of 1/2? 2. So we can multiply both sides of the equation by 2. See that? We're going to have to distribute on this side, and we would have what here? 1x plus 4y equals 6. And there you go. You now have the same equation with integer coefficients, an equivalent equation. Okay? So if you need to, you'll have to blow things up. So let's try this. Let's try writing equivalent equations in standard form. Let's start with this one here. Sometimes we have to reduce an equation, and sometimes we have to enlarge equations. So, where is this? This is the same equation in both cases. If you wanted an equivalent equation, what could we do to this one to reduce it? Lauren? We can divide both sides by 3, she says. Okay, good. And when you divide both sides by 3, you're really dividing every single term. We could write that as 3x over 3 plus 12y over 3 equals 12 over 3. We're distributing this division. Okay? And so, Lauren, give us the simplified equation then. 4y equals 4. There it is. So we can reduce equations, and we can enlarge them. Who would like to enlarge this equation here? What do you want to enlarge it by? Anybody? Give me a factor. Any factor. What? 2. 2? Okay, well, that's easy. So if we're going to enlarge this by 2, we're going to have to multiply both sides by 2, just like we saw in that other example. So go ahead, everybody, enlarge it by a factor of 2. And what do we have when we enlarge it? Sabrina?
6x plus 24y
Equals 24, yay. Okay, so keep in mind, just like fractions, equations can be written in infinite ways. You can blow them up or shrink them down. Okay. Most often we want our equations to have integer coefficients, but be otherwise in simplest form, right? So would we rather, for this equation given us right here, would we rather reduce it or enlarge it, everyone? Reduce it, because this equation here x plus 4y equals 4 has the smallest integers that you could have in its coefficients, right? If we go smaller, if we divided by something greater than 3, we would have some fraction in front of x, and we don't want that, okay? So let's do something. Let's hide something. Okay, so we are going to write a standard form equation from a graph. So take this down and then come back and we'll walk. Okay, so if we're going to write an equation in standard form from a graph, where could we begin? What's the first thing you want to get from the line that you see here? Juliana?
Your x and y.
And when you say your x and y, what do you mean? A point?
Yeah.
Okay, so we have a point. What else do we like to get from lines, Ryan? Slope. And so we can find the slope just by using the graph. And then if we have a point and slope, what can we use? Point and slope we could use? Point slope form, right? Point slope form. Look at here. Y-intercept, slope y-intercept form. Look at here. The y-intercept is kind of unclear. If it was really noted where that is crossing the y-axis, we could go straight to y-intercept. But in this case, we'll probably use point slope form because we have slope and we definitely have 2 points we could use. We'll put it in that form and then we'll transform it into standard form. Okay? So who can name the slope? Slope here is, anybody else? Who can name the slope? How about Christina? Can you name the slope?
It's 1/2.
So is it a rise or a drop? Is it a positive or negative rise?
It's a positive rise.
Going from here to here.
Oh, a negative.
So you're going -4, and then you're running a +2. So what will it be when we simplify?
-1/2.
Actually, the 4 is on top. You see that?
Oh,
So
-2.
it's -2 over 1, right?
Mhm.
So -2. And now we're going to plug that into point slope form with one of these points. So let's see, Chad, let's hear you do it. Y minus.
Y minus negative, wait,
What point do you want to use?
2.
That's a good point to use. It's like you can't go wrong. They're both 2. So y minus
2.
equals,
-4 over 2.
-2 is our slope.
-2. With x minus 2.
Good. So here we have our equation in point slope form. There we go. Okay, so here we have the equation in point slope form, but we want standard form. So we're going to have to, let's recall up here standard form, a x plus b y equals c. That's what we're going for. And so we're going to have to get everything multiplied, right? No parentheses are in that standard form equation. So we'll start by simplifying both sides of this equation. So simplify the right side for us, please, Faith.
-1 minus 2 equals -2x plus 4.
Plus 4, -2 times -2 is 4. So now what might we want to do next, do you think?
Add 2.
Add 2 so we can get these two like terms grouped up. And we have y equals,
-2x plus 6.
and this is a beautiful slope-intercept form. And so what's the last thing we need to do to get this into this standard form up here? We're going to have to move the x term to the other side of the equation. Do you see that? Because the x and the y terms are both on the left side of this equation. Okay, so how can we move it over? Good. Add 2x to both sides. And now you can say it in standard form.
2x plus 1.
There you go. Yay. Okay. Transformed all the way to standard form. Let's write two equations for this given equation, x minus y equals 3, and then write in a standard form. This is an abbreviation here, SF. It's not San Francisco. It's a standard form equation for the line through 3, -1, and 2, -3. So who'd like to come up? Okay, good. So Nico blew the fraction up by a factor of 2, and then he actually reduced the entire fraction by a factor of 2. And this is totally open to whatever you want, answers-wise. And who will come up and give us the standard form? Good job. Okay, everyone agree so far? Slope of 2? And now what are you going to do? Point slope form? We don't have a y-intercept in these 2 points. We just have 2 points, right? How do you know you have a y-intercept? You can tell me, how do you know that the point given is a y-intercept point, Emily? The x is 0, and that's not given here. So, I mean, another way would be to graph this using these points and try to see it or something, but using point slope is faster. So she plugs in, she chose 3, -1 to plug in, and -6 minus 1 is more negative. -6 minus 1 is -6 plus a -1, right? And now we have slope-intercept form, and we got to just do the final step, changing it to standard form, right? And so she's subtracting 2x from both sides, and can I extend the board up a little bit? And just come underneath it. -2x plus y equals -7. Who agrees? Did you get that?
Yeah.
Okay, but I wasn't watching totally close, but it looks good from here. If we have agreement, we're good, right? Okay, so be careful when reading your the instructions or the directions. Are you supposed to put it in point slope form, or are you supposed to put it into standard form today? Okay, any questions here? Okay, then here you go. We will not